The relational database structure has grown to become one of the most popular ways of storing data in all of IT, and is definitely the most popular with GIS. With relational databases, we have sort of a cluster of databases instead of a big flat file with a lot of blank spaces in them. This creates for very efficient storage. And the way that we relate these relational databases to one another is with some sort of key. So in this example here, if we were trying to relate the forest to the trail names here, the thing that these two have in common is the forest ID. So we would use the forest ID as a key in order to build up or join these two databases and then come up with a bigger file that would include all of the information associated with the trails, but also all of the information we're seeing in this database here. And you can see that we could join these two using that as a key, but we would not be able to join, for example, this database with this database using forest ID as a key, because they don't share that in common. We would first have to link it to this one, this to this one, and then trails by trail name to this one, and then feature and feature would link together here. And then finally we could build up a database linking or joining all four of these that would include all of this activity shown here. Let's just take a look at an example of that first part here. So in this example here, we're going to link the forest with the trails, and we're going to do it with a key, which is forest ID. So we can see here that this database here only has 2 records or rows in it. This one here has 7 in it. So our final database will also have 7 in it. It's because each one of these has to have values associated with these in the final columns here. So every time with the forest ID that we see the number 1, we would link it over here to a column here, number 1, and we would add the additional information on here, which in this case is the trail name. So this first row here, we take the Nantahala forest. It has ID 1. It has this information associated with it. We link it through its forest ID to here, and we recognize Bryson's knob as a trail in that forest. And then we put all of that into the first column or the first record of this new joined database. And then we just keep doing it. Everything that has a 1, you can see the next time we come down to the North Fork here, and so our next trail name is North Fork. The next arrow here comes down to Cades Cove, and so we have Cades Cove. We skip over that one again because the next time we see a 1 is down here for the Appalachian Trail. And then we do the same for number 2. We go number 2 over to here, Slick Rock Trail. That's the next record in our joined database. And then there's only 2 other Cades Cove and the Appalachian Trail. They would join as the next 2 records in this database. From an IT standpoint, there's all sorts of primary operators that can be used with relational databases, but by far the most common one that we use in GIS is the join. And once again, that's exactly how we just showed it. A smaller example here, where in this case we're joining by type, so that everything that has a type A would in the join database get blue, big, and old for their color, size, and age. And we can see in this case that's ID 1. And ID 4 also is joined to this, and so here we get blue, big, and old again, but everything that has a B associated with it in the type, which is the key, would get done, tiny, and old associated with it. So these 2 records or rows in the attribute table would be associated with those. So join is a fairly straightforward operation, but it's a really important one in GIS because we do it all the time.